And today we're going to talk about quadratics. Quadratics, of course, are our parabolas, right? And we have a couple different forms that we use with quadratics. We have our vertex form, which we always wrote as y equals a times x minus h squared plus k, where our vertex was at the point hk. Right? That's the form you guys remember the most. That's the one we could translate, right, left, up, down, stretch, compress, flip. We all did it from this form. We also have standard form, which we like to solve things from because it was in the form y equals ax squared plus bx plus c. Do both of those sound familiar? Good. That's good. It's a good positive starting point. All right. So first of all, when we talk about vertex form, we talk about translating. And I know you guys already know this, so I'm going to jump right into the first example. This is going to cover 13 through 21. Describe the transformation, translation, same thing, right? Relation of y equals x squared to, let's go with y equals negative 3 x minus 4 squared plus 7. So that first negative in front does what? Flip. Flips it over the which axis now? Good. Flips over x. Oops, over, sorry, x. What does 3 do? Stretch 3. All right, inside the parenthesis we have x minus 4. What does that mean? Right 4. Very good. And that last plus 7 at the end? Up 7. Excellent. Out of all that, can you tell me what is our vertex? Good. 4, 7. Very good. And we know this would open which way? It would open down. I agree. It would open this direction. Is that a max or a min? It is a maximum. All right. We did some of this. Okay, it's a maximum. Can you tell me what is the domain? Good. Negative infinity to positive infinity. What is the range? Remember, it's opening down, so there we go. Negative infinity to 7 with a bracket. Now, these are just extra bonuses. That's not part of your questions at the beginning. They just want you to describe. But I just wanted to see what you remembered before we really got into it. Okay? So, are we good with the whole translation? Yeah, I know you guys know that stuff really well, right? So, here is example number 2 then. In example number 2, find the vertex and axis of symmetry. And your equation might be something like y equals 2 times x minus 1/2 squared plus 4. So let's start with the vertex. Our vertex is at what? 1/2 and 4. Very good. So that means our axis of symmetry is always x equals, because it's a vertical line. And what does our x equal? 1/2. This is all you have to do for 23 and 25. Are we good? Good so far? Loving it. Pretty easy stuff today. All right. It's because you guys learned it so well in the first place. Okay, so now here's what I want to remind you of. Let's talk about standard form. Standard form. Okay. In standard form, which we said was y equals ax squared plus bx plus c. How do we find the vertex from this? No, good try. All right, so long ago, I told you guys there's this little equation to never ever forget, which will find you. You're close. All right, to find the x of the vertex, we do negative b over 2a. Negative b over 2a. All right, and then to find the y part of the vertex, plug in the x value. Now hopefully that sounds familiar, right? We did do it on the packet. You're probably going to see it tomorrow. All right, so here is example number 3, right? 3? All right, example number 3, find the vertex. And let's go with y equals 2x squared minus 8x plus 1. So just to remind you, of course, this is standard form, so this is our A, this is our B, and this is our C. So first, we got to do negative B over 2A. So negative 8, so it makes it a positive 8, right? Over 2 times 2, which is 2. So in our vertex, that's the x value. How do we find the y value? Plug it in. So we're going to plug it back into our equation. Y equals 2 times 2 squared minus 8 times 2 plus 1. So 2 squared is 4 times 2 is 8. Minus 16 is negative 8. Plus 1? Negative 7. And that's the y value of the vertex. So now that I know the vertex, could I write this in vertex form? So let's say now, right, in vertex form. All right, so I want to remind you very quickly. Vertex form is y equals a times x minus h squared plus k. Y equals, what is our a value? 2, very good. X minus, what's our h value? Our h value is 2, right? Squared, and then what's our k value? Negative 7. So just to remind you, I'm going to put it up here. This is our h, and this is our k. So now you could even describe the translation of what was going on from standard form, right? You're really good. All right, so what we just did here is what you have to do for 27 through 31. Does anybody want another example? Yes, you do. There's only 3 of them. 27, 29, 31. Find the vertex, write it in vertex form. All right, so how are we doing? We doing okay? So, I'm going to skip the next 3 for a second and come back to them, okay? Because I know you guys. We're going to go to the next part. So here is example number 4. In example number 4, this is going to cover 39 through 43. Right. An equation in vertex form for a parabola with vertex at, let's go, 2, -7, and through, let's go with the point 0, 5. All right, so when we do these, the first thing you have to do, step 1, is to put into vertex form. All right, so as we do that, we have y equals. We do not know what a is yet. X minus, what is our h value up there? 2, good. Squared plus k, what is our k value up there? -7. So we're all clear on what step 1 is. Step 2, plug in points. In, that's an N by the way, points. And then step 3 is going to be solve for A. All right. So here we go. Our point is 0, 5. So 5 goes in for Y. We still have A. 0 goes in for X. Now we're going to solve. Everybody okay how I plugged it in? All right. Inside this parenthesis, we have 0 minus 2, which is -2. Squared is 4. So we have 5 equals 4a minus 7. If I'm solving for a, what am I going to do? Add 7. Good. So we have 12 equals 4a. So a equals 3. I agree. We're going to take that 3, go back to our equation, and plug it in. So we have y equals 3, x minus 2 squared minus 7. You guys remember doing these too? I got a couple yes. All right, so any questions so far? Are we okay? Do you guys want another example of that? Well, we're just writing the vertex form for the equation. That's it. Okay? All right. So, now I got to backtrack to 33 through 37. I got to. All right. I want to talk about finding vertex form from standard by completing the square. I avoided it because several of you in here don't like completing the square. All right, so let's say I have y equals x squared plus 6x minus 3. We want to write this in vertex form, okay? Now, we can do negative b over 2a. That's one approach. That's what we already did, right? But the other way is by completing the square. So we're going to actually take this part, and first thing I want you to do is to rewrite this with a plus a blank, minus a blank, and then minus your 3 at the end. The reason I wrote it this way is because we're going to be adding something to this, and then we got to take it back off, right? Because that's how we keep our equation the same, right? Okay, so now we complete the square. This right here is going to make a perfect square. So we take half the middle number, which is 3, and square it. What do we get? So I'm going to put 9 in this blank. But if I add 9 to my equation, I have to take 9 back off. Now we're going to write it as a perfect square. Y equals x and half the middle number, which is plus 3, squared. That is this part right here, right? And then we're going to combine together our last two terms. So negative 9 and negative 3 is minus 12. What? Well, yeah. Okay, so what I wanted to talk about is the fact that we could take negative b over 2a, or negative 6 over 2, we get negative 3, which is our x part of our vertex, right? We can take negative 3, plug it back in, and guess what? We're going to get negative 12. This is another way of finding the exact same thing. Do I have any questions before I go on to the next example? No? We're all good? Okay. So then here's example. I'm on 5, right? Example 5. This will cover 33 through 37. Write in vertex form, given standard, use completing a square. I just want to expose you to this. Chances are you're probably going to do it the other way. That's why I'm not asking you to do a ton of these, but it is important for you to know. Okay? All right, so let's do, how about f of x equals x squared plus 16x plus 10. All right, so the first thing we're going to do is rewrite this as, I'm going to use y equals x squared plus 16x plus a blank minus a blank plus 10. I need to write this as a perfect square. So half of 16 squared. Whatever I add on, I have to take back off. Now we write it as a perfect square. Y equals x plus 8 squared. Then we combine our last two terms together. Minus 54. Exactly. Yep. Well, no, you combine that with the 10 that was on the end. That's to get the k value. Oops, let me do this. This right here, this minus 64 plus 10, is our k value. This one? Yeah, that's part of the perfect square. So, like, if I were to multiply this back out, like put it in the box and multiply it out, you get that. We have to have that so we know what we got to take back off, right? All right. Do I have time? Right, exactly. If you didn't know, you could do the x. You're going to end up with the same thing twice. Absolutely. So, this is what I want to do. If you let me do one more example, still for completing the square, we're going to leave off the 2-word problems till, I guess, Friday. Okay? All right, here's example 6. And then we will talk about those and get more into that stuff. All right, so let's do the exact same thing. Write in vertex form by completing a square. Okay? However, what did you notice about the a value on all of the ones we've done so far? It has to be 1 to complete the square. Bonus, right? So what happens if you get y equals, how about It's not that scary. 3x squared plus 6x minus 5. Nope. Okay, so we're going to do the same thing we did before, but we're going to, bless you, we're going to work with the first two terms, okay? What can I take out of the first two terms so that my a is technically 1? 3. So I'm going to put 3, x squared plus 2x plus a blank. I'm going to close my parenthesis because I've taken 3 out of that. And then I've got to subtract something off and then minus 5. Are you guys okay so far? All right, so let's complete the square on the inside. Half of 2 is? 1 squared is? All right, but really how much have I just added onto this equation? Did I just add 1? What did we add? We added 3, so we got to take 3 back off. Because if you look at, it's in parentheses, yeah? It's part of this group in here. So if I were to distribute through, that's a 3, right? Okay. So now let's just go ahead and rewrite this. This time we have y equals 3. Completing the square, we're writing it as a perfect square. It is x and half the middle number, 1. And then we combine together our last numbers. Minus 8, exactly. So the only difference is because we had a number on our x squared, we have to undistribute that. And that's going to be our stretch that sits on the outside. Not really. You just got to remember that it is actually 3 you added on that you got to take off. Okay? All right. So, yeah, you can take off those last two word problems. Just do 13 through 43 odd for me. How's that sound? All right.